I would 100% do it again. Absolutely. It changed my life and I really loved it. I thought it was so exciting to be at the cutting edge.
I've talked a lot in multiple videos on how to do clinical research in the US and in general. One topic that I haven't discussed yet about research is basic science research. And since I have not done much experience in that, I brought someone who's done a lot of basic science work in an amazing research lab in the US. Welcome, Mimi, to the channel.
Thank you. Hello, my name's Mimi Borreli. I am a PGY2, shortly going to be a PGY3, currently working at Brown. And I spent 3 years in a basic science laboratory, Dr. Longacre's laboratory in Stanford prior to residency. So I do have a lot of basic science background now, but I did not have any before I started.
Awesome. Dr. Longacre is one of the, for those who don't know Dr. Longacre, he's one of the most influential people in the plastic surgery field, especially with his basic science research. He has hundreds of publications in basic science, which is very rare to happen. I want to start by asking you, and this is a question I get asked a lot from my followers, is how do I find these type of positions? And can you tell us about your personal experience finding this position?
Yes, absolutely. So I think a first thing to think about if you are interested in exploring basic science is to really ask yourself why and make sure you're going into it with clear reasons. They could be any reason for anybody. So for me, my reasons were I needed time to do the steps. I only realized I wanted to come to the States to do my training at very after medical school, basically in my last year, but shortly before graduating. So it gave me an opportunity to come to the US to do my boards when I was here. It was also an opportunity to network and to get to know plastic surgery field. It's a very, very small world, plastic surgery. There's 11,000 plastic surgeons in the US, so everyone knows everyone. And I also, it was an opportunity to do research to build up my CV and to benefit from all the other benefits that you can gain from the lab. So that's what I wanted to do. When you have those reasons clear in your mind, then you can start investigating where to do your research. And to go about this, I think you can do a web search, but the most useful thing is talking to people and asking where labs are, who accepts people into the labs, what the labs are focused on. That's what I did when I did a sub internship at Hopkins, right? And that's what inspired me to come to the United States. And when I was there, I asked everyone how to get into plastic surgery here and what labs were available. And everyone can tell you all the possible places that you can go. And also, if you ask people, you can get their subjective or qualitative evaluation of the labs, which can help in your decision-making process as well. So then you have the list of labs and possible places that you can go and you know why you want to go. And then you've got to start emailing people. And I would be very clear in your emails when you email people. Be very professional, try and lay out your position, what your motives are and why you're attracted to their lab. Make sure your CV is up to date. You can include that in your emails. And if you've done your research before emailing people, you can include that in your email as well and say that you've spoken to these people and wait to hear back. But if you don't hear back, don't worry, email again, be persistent. If people don't email you back, it might be because they're busy. Everyone has a lot going on and are probably distracted by the multiple other commitments they have in their everyday. So for me, I emailed a bunch of people, but I emailed Dr. Longacre. I was particularly interested in his lab because I liked the research that he was doing. It was about skin scarring and fibrosis and regenerative medicine, which all sounded very exciting to me. Also, I think I really wanted to see what the West Coast in California was, this magical place. So that was also attractive. And he didn't email me back, so I emailed him a week later. And then he did email back and he said, we have a time in October we could set up for a Skype interview. But I was still in Johns Hopkins at the time, and ASPS was falling at the end of my time at Johns Hopkins in America. So I got on a flight, bought a ticket to go to the ASPS meeting and was hoping that I would see Dr. Longacre there. And I did. Actually, I had been at the bar having a couple of gin and tonics, having not seen him all day, thought I'd lost my opportunity. And then somebody was like, oh, that's Dr. Longacre. And I would encourage people to go and try and meet your PIs in person, because it's really a way that you can portray things that are impossible to portray in writing, like your interests and your motives and your enthusiasm. Those all are beyond what can be read via email. And the other things that you can do is ask people to reach around on your behalf and reach out to their friends in this small plastic surgery world.
Yeah, that's a great way of meeting mentors. Actually, my mentor at MD Anderson, after we started talking over the email, PSRC was after a month, and he was telling me like, "Would you want to come to Texas to check out the place and interview?" I was like, "We're coming to PSRC in 2 weeks. Do you want to meet there?" He said, "Yeah, I'll be there." And we met him the first time there, and this is how I spent 2 years at MD Anderson. So conferences are an amazing place to meet mentors and connect with people. So yeah. you met him, but for those who are listening, you might meet people that you have not emailed, and you can talk to them, see if there is something, an opportunity for you to be working with them. I want to emphasize about the point you mentioned, how you were interested in a particular person, particular type of research. Did you individualize the email for each person? Because I see so many international graduates and sometimes even US students, they send emails with the same template to everyone. Do you recommend making a difference in each email to reflect that you're interested in working with this particular person?
Absolutely. Yes. I think you can have a baseline structure to your email that's very similar, because often the reasons why you want to do research might be the same, but why you want to go to that lab should be completely different. Like each lab has different people that have worked there. It's in a different part of the country. There's different things that you'll be doing, different lines of research. So I would definitely not recommend sending the same email. And the worst thing that could happen is two people speak about the emails that you've sent and realize that you've sent the same template. And then you come off even worse, because it looks like you haven't done your research and you're not really being, personable. So I think making sure if your email is tailored to a specific lab, it shows that you have done your research and you know really what that lab does. And then you can say why you think it's a good fit for you and why you like it. So I would not recommend sending a blank same email to everyone.
Exactly. So another question I commonly get asked about is, what are the requirements for me to apply? Because, when you apply to the match, you have step 1, step 2, OET now, and certain requirements that you need to meet. But people are not familiar with what you need to get a basic science research position. Can you tell us about that?
Yeah, I will quote Dr. Longacre, who says, he asks 2 questions. Are you reasonably intelligent and are you hardworking? And if you answer yes to both of those, that's his only criteria. So in short, do you need any experience to get a basic science position? I would say, no, you don't. I would just say as long as you have the motivation and willing and passion, you can learn anything. Like a lot of the skills in a basic science lab are protocol driven. And it's about when you know the tools that you can use, then you can be creative and think about what you can ask with those questions. But to learn the tools, like anyone can learn them. It's just following and being, motivated and dedicated to what you're doing and being diligent. And then you can explore the whole creative side of it, which is really exciting.
Yeah, I totally echo that. Especially the same applies for clinical research. You need to show that somehow. So reasonably intelligent and hardworking has to reflect somehow on your CV with whatever you have. It might be great scores, it might be ranking high in school, it might be volunteering activity. It has to reflect somehow that you're putting some type of effort before you start emailing chairs of positions who get hundreds of emails every day.
Yeah, and just to go back to that point as well, I would say I came to the lab having 0 basic science research. And I always think that when people are considering people for a position, they would much rather hire somebody who was willing to learn than somebody who thought they knew everything. Because a year from there, the person who was willing and motivated will know more than the person who thought they knew everything already.
Exactly. I also had 0 experience. If for my followers, I had 0 experience when I started. I maybe had 1 case report before I started my research position, nothing else. That's it. So now moving on towards your experience during this research year. Can you tell us about this experience and how does your day look like? Imagine we're vlogging with you, like you're taking us day in the life of your research year. How does your day look like when you wake up? What do you do throughout the day?
Yeah, absolutely. So I think so. I spent 3 years in the lab, and I would say each year was different. So I happened to do 3 years, so I can speak about it in years, but you could also think about it in phases. So I think the first phase is you come into the lab and you, like me, if you are like me, you don't really know anything, and it's about learning skills. So in a way, you're a bit of a cost to the lab because they're teaching you, and that can take time. You can make mistakes when you're learning everything, but you can help people with their projects, and that can be a way to see how they're putting into place the skills and the available tools in the lab and the machines in the lab, and navigating where to go and who to ask and all these kind of things. And then your second phase is, well, you've learned everything, and now you can really start to try and think what you want to do and the questions that you want to ask, which aren't only related to what you're interested in, but what you have available. So they say I think Einstein said creativity only comes with knowledge. Like, you have to know that first. And that's really exciting. You can then start to design your own projects and putting them into place. And then in the third phase, in your final year, it's about making sure you're completing all your projects and then also passing on your skills and teaching the next people. And I think I was really lucky. I met a really good friend in my last year, and I taught her how. She already came with some basic science skills, and she's wonderful. But I taught her some specifics about the tools that we had here in Stanford, and she was able to help me complete the projects that I had left when I graduated from the lab. So that's overall phases. And in terms of day to day, I would say that the tasks and skills I was doing every day were hugely varied. So you have like cell work, which is cell culture, tissue processing. I did a project that used skin from humans, and we used foreskin. So I used to go to the nursery and collect foreskin in these test tubes and take them back to the lab, and then process them with enzymes and either culture them or stain them for fluorescent activated cell sorting or FACS to plate them, or to then look at their genetic data. There's histology, staining, microscopy. I loved confocal microscopy. I just loved sitting in front of the microscope and seeing all the colors, and everything looked so beautiful. It was like this entire world that was the microscopic world that I'd never appreciated really before, and it's absolutely stunning and beautiful. And some of the colors from the fluorescent antibodies and the lasers that you use, it's just awesome. I also really liked animal work. So we had a couple of projects that a lot of the projects used mice. And so the mouse surgeries was actually something I really love doing as well. You use all the micro instruments and you operate on these mice under the microscope. So it's actually really good simulation for microsurgery and plastic surgery. And then there's all the writing part. So writing grants, writing papers, reviewing articles, journal club, meetings. Meetings are really important. It's a great way to present to everybody else. Helps you be honest, like what you're producing, and then recruit feedback from other people, which can be really informative, and also hear about their projects and help them and guide them as well. And as I moved on in the lab and became more senior, I was in charge of managing other people's projects and teams and teaching them skills and making sure everyone. And I really enjoyed that component, the teaching and mentorship part of it, and have still keep in contact with a lot of the students that I helped.
So this is amazing. I can see the excitement in your eyes of talking about all these experiences you had. Now that you finished all these years, when you started, you didn't know how to do these things. Is there anyone who teaches you, for those who are listening to us, or you have to figure it on your own?
Who teaches you which?
These skills to like do the staining, to do like the microscopy stuff, the animal surgeries.
Oh yes. So I think in the lab, there's a lot of protocols that are circulated, but I definitely spent a lot of time learning from other people at the beginning, and my contribution to them teaching me was I was so grateful to be taught. I literally love being taught. So I was always so appreciative. But people are also appreciative because you help them, and if they're leaving, then you can help them. Like, a lot of it's manpower. So if you can be doing some sectioning for them, you're learning how to section, but the blocks need sectioning. So. Yeah, and then a lot of it, some of it is self-taught for sure, and some of it's about just following the protocols and helping other people to learn from them directly.
And when does your day usually start? When does it usually end, hours wise?
So my experience in the lab was many, many, many hours in the lab, every day of the week. But I had a lot to lose, so it was like make or break, and I loved it as well. And I really wanted to make the most out of my time there and be as productive as I could, and that was my objective. Rather than like say in California, I probably actually didn't go to the beach very much or see many of the different sites in California, so I need to go back to do all of that. But I would come in early, probably at like 6 o'clock, and I quite like that time in the morning when no one was there to distract you, because it can get really busy in the day and it can get hot and then everyone's speaking, and it's like if you don't, I find I just like to have that time to myself to think, take my notebook and write out what I'm going to do that day and plan it that morning. And I'll do that, reflect at the end of each day as well, what I want to achieve the next day, and then kind of set out my schedule when I get in. And there's a lot of research that shows in terms of designing school curriculum that actually if you do math-based subjects early in the morning, that's when your brain is best at dealing with mathematical things. And later in the day, we get a little bit more relaxed and creative. So I think designing your day that way can be helpful. Also, sometimes you're dependent upon, so we collected a lot of samples of human skin from plastic surgery procedures and stuff. So it would depend on when that came in. And I'd run to the OR put on my scrubs, my scrub hat, make sure I was sterile, go in and get all the samples and then take them back to the lab. And then it would be the whole day would be processing that tissue. So like chopping it up to mechanically digest it, adding enzymes to enzymatically digest it, staining it, taking it to the cell machine, and then doing all of this in one day. And then sometimes you would have meetings with people, and you have to be really, really, really organized, because you have to book these machines and make sure that you're working with people the whole time and everyone's sharing these machines. And if you have meetings, you want to make sure that you're a reliable person and stick to your word.
Yeah, and that's the difference between research and residency, because residency, there is set hours that you must be in the hospital. You have to come at 5, 6, you have to leave 6, 7, depending on when the work done. But in research, I feel it's more flexible and depends on how much you want to put in. And the more you put in, the more projects you'll have, the more publications you have. Do you agree with this idea?
Yes, I 100% do. Yeah.
So if you had to summarize your experience in the lab in 3 words, how would you explain it?
Hard work, for sure. Inspirational and life-changing.
So when people are looking for research positions in basic science, what are the different options that are available, and how do different labs differ from each other?
I think types of basic science can be categorized by the level of training you have when you're starting your basic science, because there's probably a hierarchy or a different class of people who are in a lab. So you have your PhD students are probably the top, right? They have their like 3-4 year project that they're doing, and they get a lot of funding from an institution, and they will primarily work on their stuff. You have postdocs, who are people who can come. So anyone can do a PhD. You can come if you apply. You can do it out of medical school, before medical school, in residency, after residency. You can also come as a postdoc. So this means after you've got your doctorate. That's what I went to the lab as. And as a postdoc, you are more involved in administrative tasks for the entire lab and like teaching and training other people, as well as like writing grants. And you likely have some of your own projects that you're doing, or you definitely do, but you also help oversee other people's projects as well. So a more kind of managerial role, I would say. You can come during medical school and be a student in the lab. Often if you do that, or you come as a pre-med, you are probably there for a shorter time, at least in my experience. In the lab, and you may have some of your own projects, but primarily you're there learning the skills and getting an insight into what basic science is like, what the field is like, and you're helping other people with their projects, and they're teaching you in response, and that's the collaboration there. So that's one way of categorizing different types of basic science. Another way would be the focus of the lab. So different labs ask different clinical questions, and to ask those different clinical questions, they involve different skills.
Now moving on to the expectations and the decision making whether to pursue basic science research or clinical. I get asked from multiple students, should I do basic science or clinical, especially for those who are applying to the match. What is your take on the advantages and disadvantages of basic science research? And what do you recommend for students applying to the match in different specialties, not necessarily in plastic surgery?
Okay, so I think the main differences with basic science versus clinical research, if people are asking those two questions, are basic science is probably much more of a time investment. Like it takes time. It takes time to learn those things. You're not really, you spend the first phase of your experience in the lab learning, and that can be a long time, and you're at cost. And it's like really, so I stayed in the lab 3 years. Initially, I wanted to do 2 years, but actually I'm so grateful I did 3, because what you learn in your first year and your second year is like cumulative. So like in the second year, you learn way more than you did in the first year, and you're way more valuable. But then in the third year, it's like the curve is exponential. Like if I stay there another 4 or 5 years, like it would probably be like way beyond what I could have achieved in the third year. So each year is not the sum of the previous one, it's more. And so I think if you're able to commit that time, that's probably one of the key differences. And also the stakes can be, the rewards can be really great. Like you can produce really high quality work. And if you're motivated by producing scientific results which you think are going to help change the pathway and the field, and that's something that excites you, I think probably doing basic science research is arguably more effective in that, to answer that question, because a lot of clinical research is retrospective case series or that you can also do in residency. I think basic science is very difficult to do in residency because of how much more involved it is. So you probably will produce fewer amounts of higher quality work. But then because they're higher quality, and if they have more impact on the field and more impact on the literature. And also if you go to do a basic science lab, you can also probably do clinical science at the same time.
Whether you would recommend, like if people are applying to the match, what is the best option for them?
So I think if you're able to commit the time, that's one thing. Other advantages or disadvantages. So basic science is hard work. It's a lot of hours, and sometimes there's a lot of failure. So you have to have a resilience to learn from your mistakes and be able to deal with experiments repeatedly not working and not working and not working. So for example, our cell culture for like a whole month just kept on like not working, and then we realized we probably had a fungus infection in the incubator, and we like cleaned it all out, and then it all magically worked. But you have to be like good at problem solving and getting to the problem, getting to the base of the problem and why something's not working. So dealing with failure, having the ability to commit time, and putting in the hard work are probably the things that I would say the main differences between that and clinical research, and how much of an impact that you care about making. But like clinical research is something that you can do throughout. If you spend a year doing clinical research, you'll probably put out a lot of papers. And if your objective is to publish as much as you can, maybe that, and you don't have so much time, and you have a lot of other commitments in your life going on, maybe a clinical lab is better for you.
Yeah, because as you said, in basic science research, I feel there is a high chance of like experiments not working. And you have to repeat and repeat. And maybe after a full year of work, you realize that this part does not work, which is valuable information, but you might not get a publication from that, or recognizable something on your CV. You can mention the experience, but you can't get a paper out of experiment that failed.
Yes, exactly.
Now talking about mistakes that people should avoid when they are in the basic science position or we're looking for one. What do you think that from your experience or experience of other people you worked with are mistakes that people should pay attention to and avoid?
Okay, so to start with, I think choosing the wrong lab could be the first mistake. So I think you should choose somewhere that's a good fit for you, that makes sure that it will deliver be in line with your dreams. That's why I mentioned before, being dream orientated is something I really, really preach. Like, you have got to work out what you want. And then you've got to make sure when you go, you keep that dream in mind, because it's your career and your life, and you can make everything additive if you know where you want to go. And also, it doesn't matter if your dream changes, but at least if you have a dream that you're following, then it can help give you direction and guide you. So that can help choose the right lab for you. Like, do you want to go to meet the people there? Are you interested in the research there? Do you want to be super productive and making sure that you choose somewhere initially? Because once you're in, like, that's a year, 2 years of your life that's going to be life-changing. Those experiences are going to be with you forever. So making sure you go in, and the way that you can do that, as well as by really speaking to a lot of people. Like, I spoke to a lot of different Longacre graduates before I contacted Dr. Longacre to be like, is this right for me? Like, do I want to do this? And people would tell me it's a lot of hard work. And I was like, that's great. I want to work really hard. So I thought it was like a good fit from that. I would say, related to dreams, like losing focus and losing sight of your overall goal is something to avoid by being goal driven. I would say a real thing you have to do when you're in the lab is being very organized and meticulous, because you really need to write good notes. Everything needs to be properly labeled, because everything looks the same. Like, the cell culture dishes look the same, but one has some topical agent, another one has something different, and you only know by this labeling that you've done. So you're very, very dependent on it. And if you don't finish your projects, but you don't have anything labeled, no one can help finish them for you when you leave. So I would say being very, very organized can help you make the most of your time, especially if you are trying to achieve a lot in a very short time, and you're involving other people, you're working around other people, you're all booking the same instruments, you're sharing the space, and it's important to respect other people as well. And I would say to avoid getting involved and trapped in any politics or any bad relationships, because that could be really disastrous. You want to make sure that you're collegial and a good person, and you have your integrity, and at least you're being nice, because sometimes it can get competitive in labs when everyone has very similar projects, doing some things, asking similar questions, and some people might be more successful and have a really exciting result, and then you don't. And we're expecting everyone's different. Everyone has different objectives and goals, and not competing with anyone, just competing with yourself and making sure that you are collegial and a good person, because that's what makes me happy.
That's really great advice. Now, going to our next question. Did you like doing research? And if you go back in time, would you do this again?
I would 100% do it again. Absolutely. It changed my life, and I really loved it. I thought it was so exciting to be at the cutting edge and really asking questions that you think can make a difference. Like, that is so amazing, to be able to contribute to the world and science and advancement of our field. Like, that gave me a real exciting feeling. And it's a place of learning. If you want to learn, there's so many things to learn, and there's so many people who can teach you. And I love being taught and like seeing all these different things that everyone's doing, and the people. Like, I think it was a really interesting experience for me to meet people who had such different backgrounds from me that I'd never ever would have encountered before. And that was just very intriguing and fascinating to learn about all these different lives that we're all living on the same planet that we had no idea. I think added being from the UK, it was like, oh, I was learning all about American culture and the different kind of pathways and culture of America. And it gave me so many skills. So I loved all the basic science. I don't know if I'm going to do basic science in the future, but there's so many transferable skills, like the organization, the leadership, like managing teams, being preparing for your life, and just helping really take charge of the things that you want to do, and then executing them and doing them. And it's like it's something that you're totally dependent on yourself to do, in a way. So your success is the amount of work that you put in equals the amount of work that you get out. And I quite like that.
That's awesome. Now we're approaching the end of our interview. Do you have any final advice for people who are pursuing or looking to pursue basic science research in the US?
Yes. Number one, I would say define your dream. self-reflect, work out what it is, apply all your introspection, ask people, talk to people, work out what their dreams are, work out whether that fits with you. Everyone is different, and appreciating that and acknowledging that is very powerful. And then you can follow your dream, because I think we should all follow our dreams. But America is a place that if you want things to happen, they can happen. You just got to put in the hard work and do it. I think another bit of advice I would say is work hard, because if you are going to spend the time doing that, make the most of it. And nothing worthwhile in life is ever easy. That was another Longacre quote, but I like that as well, because it helps you get through the nitty gritty. Like, we all spend a lot of our day doing things that we don't want to do every day in order to be doing the things that we do want to do. And then trying to find, if you don't want to do something, trying to find actually why you might want to do it, or the enjoyable things in that thing can be another empowering trail of thought that can actually make you happier in life. And last thing I would say, have integrity. Being an honest, open, altruistic person, I think is something that I realize brings me the most amount of joy in my life. As long as I always make decisions that I'm happy with, like as long as I make sure I have the integrity and do the best for patient care, for example, that's always something that I can never be faulted for in my self-criticizing mind. And I would say it's better to give and not expect anyone to give back, and then you're only ever going to be pleasantly surprised.
Awesome. These are really great recommendations and advices for future students. And I always say it's about the journey. It's not only about the goal. Achieving the goal is amazing, but it's about the journey, because if you're just goal-driven and you don't enjoy the process, it's not going to be fun.
Yes, 100%. It's definitely about the journey. Enjoy the journey.
Thank you. Thank you so much, Mimi, for this amazing discussion about basic science research. I really appreciate your time. I know you're extremely busy, and this was extremely insightful discussion about basic science research.
You're welcome. Thank you for inviting me to.
Of course. For our viewers, if you have any questions, leave them in the comments below, or feel free to reach out to me on Instagram, Twitter at Malki Assad, my Facebook page, Malki Assad MD, or if you want to schedule a consultation to discuss more in detail your dreams, what you want to do in the future, recommendations about whatever pathway you want to do, we have one-on-one sessions that you can schedule on our website, and we'll be happy to guide you through the process. If you like this video, make sure to hit the like button and subscribe to the channel, and hit the bell sign so you get notified whenever I post future videos on my YouTube channel. Thank you everyone so much for watching, and see you in future videos.